So when we put a laser onto a device that will run it in the field, we call it a laser scarecrow. I have with me today a laser scarecrow that was developed by the University of Rhode Island. It's a research laser scarecrow, and I want to use it to illustrate the components of a laser scarecrow. This particular model is all held within, in this case, a 3-gallon plastic bucket to keep everything waterproof. It usually has a lid on top. And the laser is in a holder that the laser hangs down. This particular laser uses a Class 3B laser beam, and it comes with a danger warning to avoid any eye contact with the laser itself. So we have heard of some other lasers being sold on the internet that have Class 4 lasers, which are very high powered. They can really cause damage to your eyes, and it can also even burn the crop. If you are looking to purchase a laser, please make sure you understand which laser beam you're using, the power, and what the safety features are. Generally, a laser has motors that move it in response to either random patterns or other factors in the field. This particular laser can move 360 degrees, and the motors control it to move in very random patterns. This laser also has an up and down motion. It cannot go any higher than horizontal because we don't want to project it at airplanes or roads, which would be very hazardous because lasers can cause flash blindness. Here's a look at the inside of the bucket. Normally there's a cover there, but it's showing the motor. This is a stepper motor and the circuitry that's used to drive this laser. This particular laser also has a light sensor, which is here where this black button is. And so the laser will turn on in the morning when there's enough light, and it turns itself off at dark because the laser is not needed during the nighttime. The birds are not out in the field during that time. It also saves on our battery. So I have this laser set up next to a road and concerned about the laser shining into the road. This particular laser model has a tape sensor, and we have a piece of black tape against the white bucket. The tape sensor reads that tape there and it turns the laser off. But for double protection, I have put a shield. I've taped this plastic shield there so no light can shine into the road. The optimal setup of a laser scarecrow in sweet corn, in reality, I would like to be in the middle of a field with the laser turning around 360. It almost forms a cone of protection for the crop. But in this case, since we're near a road, we have a field that's sloping down, we have a couple of lasers on the edge of the field. We want this laser beam to shine right through the tassels of the sweet corn plants. That way the birds won't perch on the sweet corn. I have also seen this work really well where flocks of birds are in the air and they're trying to land and they become disoriented from the laser, and hopefully they just move elsewhere. We did have a situation when we had really heavy bird pressure this year that the birds actually flew underneath the beam and were getting into the edge of the field. That's where some other bird deterrents can come in handy. When I'm setting this up in sweet corn, in order to see if I am at tassel level, I can't see it during the daytime, so I find that holding up a white poster board is really useful because you can see the reflection of the green beam on the board. This has a little bit of an up and down motion, so you may see it at different levels on the board here. Again, we never want to look at the laser beam directly. Another way of looking to see if the laser is set up properly is to come out on a really cloudy, rainy day or right at dusk or at dawn, and then you can see the laser moving across the field hitting the plants. It's a really good way to see if you have things adjusted properly. Of course, you can also see if birds are starting to come in the field. what their reaction is, you might need to make some adjustments.